Welcome to Aeronet's visual simulation training program for the Airbus A320. The A320 fuel system stores fuel in the fuel tanks, controls the distribution of fuel during refuel and defuel operations, supplies fuel to the engines and APU, cools the integrated drive generator oil, and supplies information to ECAM and cockpit indicators. Controls and indicators are found on the overhead fuel panel, the refueling control panel on the wing, and on the ECAM display. Wing and center tank fuel pump switches, the crossfeed selector, and the mode select switch are located on the overhead fuel panel. The ECAM fuel page is automatically displayed with any fuel system caution and can be selected at any time with the fuel button on the ECAM control panel located on the pedestal. The refueling control panel is located under the wing on the left-hand side of the aircraft. A refuel coupling is installed under each wing, allowing the refueling hose to be connected to either the left-hand or right-hand side of the aircraft. The fuel is stored in 3 tanks: the left-hand wing tank, the right-hand wing tank, and the center tank. The wing tanks are further divided into an inner cell and an outer cell. The total usable fuel capacity is 23,858 liters, or 6,302 U.S. gallons. There is an additional total of 82 liters of unusable fuel within the system. When the tanks are completely filled, an allowance of up to 2% total capacity is provided within the system to allow for expansion due to temperature rise. The ECAM fuel page displays the fuel quantities in each tank. The total fuel on board is displayed on both the upper and lower ECAM. Additional fuel system information is shown on the upper ECAM memo display. Fuel is held in the outer wing tanks to reduce wing bending and to control wing flutter during flight. 2 fuel level sensing control units, or FLSCUs, control the transfer of fuel from the wing tank outer cells to the inner cells when the quantity in either inner tank reaches approximately 1,650 pounds. There are 2 transfer valves in each wing. At least 1 valve in each wing opens simultaneously with a valve in the opposite wing, allowing fuel to flow evenly by gravity into the inner cell. They close automatically at the next refueling if AC power is connected to the aircraft. Transfer valve position is indicated to the crew on the ECAM fuel page and on the upper ECAM memo display. The valves shown in the green vertical position indicate they are closed. Displayed in green horizontally, it indicates at least 1 valve is in the open position. If displayed in amber, the valve is not in the correct position as determined by the fuel level in the inner tank. Once the fuel transfer valves have opened, the message "Outer tank fuel transferred" is displayed on the upper ECAM memo display. The vent surge tanks hold overflow fuel temporarily to prevent spillage during aircraft movement on the ground and during rotation at takeoff. They have a capacity of 190 liters or 50 U.S. gallons. Fuel that enters the vent surge tanks is moved to its related wing tank by scavenged jet pumps. If a failure in the fuel system causes large quantities of fuel to enter the vent surge tank, the fuel is dumped overboard through a vent duct. The tank vent system equalizes the pressure between the inside of the fuel tanks and the ambient air. This is especially important during refuel and defuel operations and while the aircraft climbs or descends. The left-hand vent surge tank vents the left-hand wing tank and the center tank. The right-hand vent surge tank vents the right-hand wing tank. Overpressure protectors in the form of burst discs are installed in the tanks, which break at a specified limit if a blockage occurs in the vent system. Some of the fuel supplied to each engine is passed through the oil cooling system of its associated integrated drive generator, or IDG. After the cool fuel is circulated through a heat exchanger, it is returned to the wing tank outer cell through the fuel return valve, or FRV. FADEC, along with the FLSCU, controls the FRV and stops the recirculation system if the fuel temperature increases to a high level of approximately 53 degrees. The engines are demanding a high fuel flow rate. The engines have gravity feed only. The fuel level in each wing tank is less than 620 pounds, or there is fuel in the vent surge tank. A cross-feed valve allows the two sides of the system to be interconnected so that tank pumps from one side can supply both engines. Normally the valve is closed and the two sides are isolated. The cross-feed valve is controlled by the cross-feed push-button switch located on the overhead fuel panel. The valve actuator has two motors, each supplied by a different power source. When the push-button switch is pushed in, the white on light illuminates, and when the valve is fully open, the green open light illuminates on the switch. Select the cross-feed push-button switch to the on position. The cross-feed valve position is also shown on the ECAM fuel page. A green cross line indicates the valve is closed. Inline in green indicates the valve is open. The valve display is amber when the valve is in transit. An amber cross line indicates the valve is closed when the push-button switch is selected on. Inline in amber indicates the valve is open when the push-button switch is off. The message, "Fuel Crossfeed," is displayed on the upper ECAM memo section when the crossfeed valve is open. There are 6 main fuel pumps, 2 in each inner wing tank and 2 in the center tank. All fuel pumps are identical and interchangeable. They are installed in a protected canister, which makes replacement possible even when there is fuel in the fuel tank. The canisters are enclosed in collector cells, which ensure the pumps are always fully submerged in fuel during all flight maneuvers. Each pump is thermally protected. If a pump overheats to greater than 175 degrees, it stops and must be replaced. When the wing tank pumps are selected on, they operate continuously until they are switched off manually. Fuel pump switches are located on the overhead fuel panel. When the switches are pushed in, the pump is on, and the switch lights are not illuminated. Select the wing tank fuel pumps on. Wing tank fuel pump indications are shown on the ECAM fuel page. Inline in green, pump pressure is normal. An amber boxed low indicates pump pressure is low when the switch is on. Cross-line in amber, the pump has been selected off. The center tank pumps have 2 modes of operation, manual and automatic. The mode selector push-button switch determines which mode is in operation. With the push-button switch released to the manual mode, the center tank fuel pumps are selected on or off with the center tank pump switches. Wing tank pumps each have sequence valves, which ensure that the center tank pumps supply fuel preferentially when they are selected on. Fuel is normally supplied from the center tank first, then from the wing tanks. Select the center tank fuel pump switches on. With the mode selector push-button switch pushed in and the center tank pump switches 1 and 2 on, the system operates in the automatic mode. After engine start, the center tank pumps run for 2 minutes and then stop. After takeoff, the center tank pumps will run again once the slats are retracted and the level in the on-side inner wing tank has dropped 1,100 pounds. Fuel return from the IDG recirculation system may cause the wing tank to refill. This stops the center tank pump until the level in the tank again drops 1,100 pounds. When the low-level sensors detect that the tank is empty, the pump will run for an additional 5 minutes and then stop. Indications for the center tank fuel pumps are shown on the ECAM fuel page and are identical to wing tank pump indications, except that a green cross line indicates the auto function has turned the pump off when the mode selector is in auto. When the center tank pumps are off or have failed, the fuel on board indication is boxed in amber on the lower ECAM and half boxed in amber on the upper ECAM. The fuel to each engine passes through its associated low-pressure fuel valve. The valve is controlled by its related engine master switch and engine fire push-button switch. The valve position is shown on the ECAM fuel page. In line and green indicates the valve is open. A cross line in green indicates the valve is closed. A cross line in amber indicates the valve is closed when it should be open. Inline and amber indicates it is open when it should be closed. The valve is shown in amber when it is in transit. Suction valves are installed in each wing tank collector cell. If both fuel pumps fail in a wing tank, the engines can use suction pressure to extract fuel from the tanks. Note, suction valves are not installed in the center tank. Therefore, if both center tank pumps fail, fuel is not available from the center tank. The APU fuel pump is installed near the center fuel tank, but uses fuel from the left-hand side of the fuel system. It starts automatically whenever the APU master switch is on and the tank fuel pumps are off. The APU low-pressure fuel shutoff valve, when open, allows fuel to flow from the fuel tank to the APU. It is controlled by the APU master switch, the APU fire push-button switch, and the APU shutoff switch on the external panel. Touch the APU master switch to turn the APU fuel pump on. The Fuel Level Sensing System, or FLSS, consists of fuel level sensors and fuel temperature sensors installed in various locations throughout the fuel tanks and two fuel level sensing control units, or FLSCUs. The FLSCUs continuously monitor the fuel level and temperature sensors and use this data for the following: commands FADEC to close the fuel return valve when fuel returned from the IDG recirculation system is too warm, opens the intercell transfer valves when the inner tank quantity reaches 1,650 pounds, transmits the low-level warning when wing tank fuel drops to 1,650 pounds, turns center tank pumps on and off in automatic mode, and gives high-level shutoff information for refuel operation. Fuel quantity and temperature information is supplied to the ECAM fuel page. Total fuel on board, or FOB, is also found on the upper ECAM. Two dashed amber lines across the last two digits indicates the FQIC is in a degraded mode. Manual magnetic indicators, or MMIs, are a direct reading secondary system for calculating the fuel quantity on the ground when the ECAM tank quantity indications are inoperative. It is not necessary to have electrical power. They are extended from the bottom of the wing to give readings which, when combined with aircraft attitude and fuel density information, is applied to published tables to calculate the amount of fuel in the tank. The refuel valves can be controlled either automatically or manually. Automatic refueling is accomplished by selecting the Mode Select switch to refuel, pre-selecting the required amount with the pre-selector rocker switch, and leaving the refuel valve switches in the norm position. The refuel valves are controlled by the FQIC and open when refueling pressure is available. During refueling, the wing tank outer cells fill first. When the outer cell is full, fuel flows through a spill pipe into the inner cell. If the FQIC determines that fuel is required in the center tank, it fills simultaneously with the wing tanks. When a fuel tank becomes full, its associated high-level light illuminates. When the desired amount has been loaded, the end light illuminates. Touch the pre-selector rocker switch to pre-select the required fuel load of 27,000 pounds. Then touch the fueling hose to begin refueling. Manual refueling is accomplished by selecting the refuel valves to open individually as required. The selector switches must be placed to shut when the desired fuel quantity has been reached in each tank. Remember, the wing tanks must be full if fuel is to be loaded in the center tank. High-level sensors will still close the refuel valves when the tanks become full. It is also possible to refuel the aircraft via over-wing refuel caps when pressure refueling is not available. Over-wing refueling is only possible to the wing tanks. If fuel is required in the center tank, it is necessary to transfer fuel through the defuel transfer valve using wing tank fuel pumps. Defueling is also possible. The main fuel pumps remove the fuel from the tanks through the defuel transfer valve into the refuel gallery and supply it back to the refuel coupling where it can be removed from the aircraft.
The minimum fuel quantity for takeoff is 3,307 pounds. The wing tank low-level warning must not be displayed on ECAM. The maximum fuel imbalance between outer tanks is 1,168 pounds. Between inner tanks, the maximum imbalance is from 3,307 to 4,960 pounds, depending on inner tank quantity. Refer to FCOM 3 operating limitations for further information.
Fuel in the center tank must be used before fuel in the wing tanks. Takeoff with center tank fuel pumps operating is prohibited. The minimum fuel temperature for type Jet A is -36 degrees Celsius. For Jet A1, the minimum temperature is -43 degrees Celsius. The maximum fuel temperature for both Jet A and A1 is +54 degrees Celsius. For other fuel types, refer to FCOM 3 operating limitations. The maximum refueling pressure is 50 psi. The maximum defueling pressure is 11 psi. Select all 4 left and right tank pump switches on. If fuel is loaded in the center tank, select the center tank pump switches to on and the mode selector to auto, otherwise leave them off. Confirm total fuel on board on the eCam fuel page with the flight plan fuel requirement. Also, check that the fuel is properly loaded. That is, fuel in the wing tanks should be balanced. The outer cells should be full, and if there is fuel in the center tank, wing tanks must be full. With the mode select switch in auto, the center tank's pumps shut off 5 minutes after the center tank is empty. However, due to turbulence or attitude changes, the low-level sensors could become wet again and restart the pumps for an additional 5 minutes. The pumps may be damaged if they run dry for long periods. Therefore, when the center tank fuel is exhausted, the center tank pumps should be selected off and the mode select push-button switch selected to manual. If a fuel imbalance develops between wing tanks and it is desired to balance the fuel, select the crossfeed valve on. The green open light illuminates when the valve is open. Then, turn both wing tank pumps on the low side to off. When the fuel is again balanced, select the tank pumps back to on, then the crossfeed off. If there is fuel in the center tank pumps must first be turned off. Then, select the crossfeed on and the wing tank pumps on the low side off. When the fuel is balanced, turn the tank pumps on, select the crossfeed off, and the center tank pumps on. Normally just before or during descent, depending on the fuel on board. The inner cell low-level quantity of 1,650 pounds will be reached, and the intercell transfer valves will open. Occasionally during steep descent angles, the low-level sensors may be uncovered prematurely, which causes the transfer valve indication on the eCam fuel page to display in amber. In this case, the amber indication may be disregarded unless the fuel transfer valve open warning is triggered. All fuel pump switches are selected off, and the mode select switch is selected to manual after engine shutdown. The failure of a single wing tank pump illuminates the fault light of the affected pump switch and the low pressure indication on the ECAM fuel page. Select the affected pump switch off, then touch the right arrow to continue. With the failure of two wing tank pumps, when the center tank is empty, the procedure calls for the cross feed on, engine mode selector to ignition, and the failed pumps in the affected tank to off. Both engines will now be fed from one side. Accomplish the ECAM actions, then touch the right arrow when ready. Now would be a good time to review the gravity fuel feeding procedure in FCOM 3. Considering fuel requirements and that there is an imbalance limitation, it may eventually be necessary to use fuel from the affected tank. When the left tank fuel is required, and if at the altitude determined by the chart in the gravity fuel feeding procedure, confirm the engine mode selector is set to The associated engine is now fed by gravity only. Clear fuel by pressing the Clear button on the ECAM control panel. The status page reminds the pilot that the left tank is being fed by gravity feed only. Avoiding negative G factors will prevent fuel surging and the risk of engine flameout. Note the center tank pumps are inoperative because the center tank is empty. Clear status by pressing the Clear button on the ECAM control panel. When the total fuel quantity in a wing tank drops below 1,650 pounds, the low-level fuel sensor triggers the low-level warning and brings up the ECAM fuel page. When the quantity in both tanks is low, the message, "Land as soon as possible," is also displayed. There is approximately 30 minutes of flight time remaining. If any fuel pumps are off, ECAM reminds you to turn them on. Touch the right arrow to continue. If the intercell transfer valves fail to open when the inner tank low level is sensed, this warning is triggered along with the master caution and single chime. The outer tank fuel of approximately 1,500 pounds is not available. Soon after, the wing tank low-level warning will be triggered for the affected tank. Touch the right arrow to continue. If a transfer valve opens prematurely, a slight imbalance condition will occur as the fuel flows from the outer to the inner sail on one side only. Crew awareness is required. Once the opposite wing tank fuel transfers at the appropriate time, the fuel should be balanced. Touch the right arrow to continue. With fuel feeding from the center tank, the failure of a center tank fuel pump requires that the crossfeed be opened to prevent a fuel imbalance. Once the center tank is empty, the remaining center tank fuel pump should be switched off and the crossfeed closed. Perform the ECAM actions, then touch the right arrow to continue. The failure of both center tank pumps means that any fuel remaining in the center tank is unusable. Gravity feed from the center tank is not possible because suction valves are not fitted on center tank pumps. Select the center tank pumps off, then touch the right arrow to continue. With fuel in the center tank and the fuel mode selector in auto, this warning will be triggered if the center tank pumps shut off prematurely or run when they should be inhibited. Selecting the fuel mode selector to manual will cause the center tank pumps to run continuously when they are selected on. Remember, takeoff with the center tank pumps operating is not allowed. Therefore, select the center tank pumps to off prior to takeoff and on again once the slats are retracted. When the fuel in the center tank is exhausted, the center tank low pressure warning will illuminate and the center tank pumps should be selected off. Refer to the MEL automatic fuel feed system. Touch the right arrow to continue.